Saisarth classes. Join Saisarth classes and fulfill your dream.
Today we are going to discuss about a third chapter from the chemistry paper, that is ionic equilibrium. जैसे कि हमने पहले इक्विलिब्रियम के बारे में डिस्कस किया 11th स्टैंडर्ड में, इक्विलिब्रियम दो तरह के होते हैं। एक होता है फिजिकल इक्विलिब्रियम, एक होता है केमिकल इक्विलिब्रियम। सबसे पहले फिजिकल इक्विलिब्रियम क्या है? सो सपोज वी हैव द वाटर इन इट्स लिक्विड स्टेट एंड वी आर कन्वर्टिंग द वाटर इनटू लिक्विड स्टेट टू इनटू इट्स गैसियस स्टेट. The process of conversion of water from liquid state to a gaseous state is nothing but the vaporization, and the process of conversion of steam into its liquid state is nothing but the condensation. Suppose the rate of vaporization and rate of condensation are equal. It means that the rate of forward process and rate of backward process are equal. The such kind of equilibrium is considered physical equilibrium. So we can simply say that the equilibrium established between the two states of the same substance is called as a physical equilibrium. Let's talk about another kind of equilibrium, that is a chemical equilibrium. Chemical equilibrium is established between the two chemical species, that is a reactant and product. Suppose there are two reactants, A reactant react with the B to form the product C plus D, and the product C plus D react with each other again to form the reactant A plus B. It means that there are two reactions occurring, forward and backward. If a rate of forward reaction, rate of a forward reaction and rate of backward reaction becomes equal, the rate of forward reaction and rate of backward reaction becomes equal, then it is said that the equilibrium is established between the two species, reactant and product. Such equilibrium is called as a chemical. Let's talk about the ionic species. There are two types of ionic species, that is cation and anion. How cation and anion is formed? The cations are formed by positive charge species, and anion is nothing but the negative charge species. Most important thing is that how this charge rises. For example, Na plus and Cl minus, it's the atomic charge species Na plus and Cl minus, and the NH4 plus SO2 minus, these are the group of atoms which carry the charge. So these positive charge species, these are the negative charge species. A positive charge species are called as cation. A negative charge species is called as anion. This positive charge rises due to a loss of electron, and this negative charge species generally rises due to the gain of electron. This is a simple phenomenon behind the formation of ionic species, cation and anion. So cation formed by loss of electron, anions are formed by gain of electron. So when this cation Na plus and Cl minus combine with each other, they form the neutral molecule like the NaCl, or H plus and Cl minus combine with each other to form the neutral molecule like the HCl, and the ion like Na plus and OH minus, this side combines with each other to form the NaOH. So these are the neutral molecules formed by the combination of cations and anions. This NaCl is nothing but the salt, HCl is nothing but the acid, and the NaOH is nothing but the base. So salt, acid or base, they form the reverse when they are dissolved in water. When the salt like the NaCl dissolve in water, it dissociates into its ion Na plus and Cl minus, aqueous. HCl is formed like the H plus and Cl minus in its aqueous solution, and the NaOH is like the Na plus and OH minus, aqueous, aqueous. So these are the termed as electrolytes. We have the discussion about two important concepts. The first one is that the equilibrium, and second thing is that the ionic species. Let's talk about the next concept. Suppose we have the substance AB, and AB is just added in water. When the compound AB is added in water, is dissociated into the two components A plus plus B minus, aqueous, aqueous. It simply means that the substance AB dissolved in water, it produces its two ions, cation and anion, A plus and B minus. Such substance is called as electrolyte. So what we can talk about electrolyte? Electrolytes are substances when dissolved in water, dissociate into its ion, A plus and B minus. This is all about the electrolyte. So which are the general examples of electrolyte? We can say about the salt, acid or base. A salt like NaCl. NaCl when dissolved in water, it produces the two ions, Na plus, Cl minus. Acid like HCl, when dissolved in water, it produces two ions, H plus plus and Cl minus. And the base like the NaOH, when dissolved in water, it again produces the two ions, that is the Na plus plus OH minus. So all the three species is salt NaCl, acid HCl and base NaOH. When dissolved in water, they dissociate into the component Na plus Cl minus, H plus Cl minus, Na plus and OH minus. Simply we can summarize into cation and anion. So substances which are dissolving in the water produces cations and anions are simply termed as electrolytes. There are two types of electrolyte: strong electrolyte and weak electrolyte. So this type of electrolyte is, it simply depends on the extent of dissociation of a substance into its ion. For example, we have HCl. When HCl is dissolved in water, HCl dissociates H plus plus Cl minus. Suppose for example, we have the 100 molecules of HCl at initial. Before the dissociation, the number of ions produced by the HCl is 0, 0. But after some time, the number of undissociated molecules are 0 and the number of H plus ions are 100 and number of Cl ions are 100. It means that the HCl dissociates almost completely. Such a kind of electrolyte is called as a strong electrolyte. But when you look out for the acetic acid, a CH3COOH, acetic acid is a weak electrolyte, is dissociated in a reversible manner, like the CH3CO minus and plus H plus. Suppose initially we have the 100 molecules of HCl. This is just for an example. The 0 acetate and H plus ions are there. But after some time, out of 100, 80 molecules remains undissociated. Only 20 molecules are dissociated into its ion. It means that the acetic acid dissociated to very less extent. The most of the molecules of acetic acid remains undissociated. But only the 20 molecules of acetic acid out of 100 get dissociated into the cation and anion. So it is called as a weak electrolyte. So there are two types of electrolyte: strong electrolyte and weak electrolyte. So what is strong electrolyte? All molecules on dissolving in water dissociate completely into cation and anion. It is a strong electrolyte, and if all molecules do not dissociate completely, into its ion, it's called as a weak electrolyte. So depending on degree of dissociation, electrolytes are two types: strong and weak one. The substance which dissociates almost completely into its ion is called a strong electrolyte, and substance which do not dissociate completely into its ion is called as a weak electrolyte. So to decide the strength of weak electrolyte, how much it is stronger or how much it is weaker, compare the strength of a dissociation of weak electrolyte. We have the concept of degree of dissociation. The degree of dissociation is symbolized by alpha. What is degree of dissociation? It's nothing but the ratio of number of moles dissociate into its ions to the number of moles of electrolyte dissolved into water. Suppose electrolyte is strong. When you look out toward a strong electrolyte, the HCl, the number of moles of HCl dissolved in water are 100, and number of moles of HCl dissociated into its ion are also 100. So alpha is nearly equal to 1 if the electrolyte is strong. But if electrolyte is weak, like the acetic acid, then the value of alpha should be, out of 100 dissolved molecule, only 20 are dissociated. So ratio is nearly equal to 0.2. It means alpha is a very less when the less than 1 if the electrolyte is a weak. So to study the nature of electrolyte, whether it is a strong electrolyte, whether it is a weak electrolyte, we can use the concept degree of dissociation. This is all about the concept of strong electrolyte, weak electrolyte, and degree of dissociation. We are discussing about electrolytes. There are 3 types of electrolytes: acid, base, and salts. Right now we are talking about the acid and bases. At the time when the chemistry is not too much developed, so acids and bases are easily classified on the basis of their property. The first thing is that the classification of acid and bases on the basis of their property is called a classical concept. So how to distinguish between the acid and bases on the basis of their property? Let's look out there. Acid. Acid is a sour in test, while bases are bitter in test. When acid react with the metal, they liberate the hydrogen gas. At the other hand side, the bases are soapy to touch. Acid can neutralize the base, and base can neutralize the acid. What everybody knows about the neutralization. Acid when react with the base, they form the simply salt and water. And finally, the most important test, that is a litmus paper test. Acids are capable to convert the blue color of the litmus paper into the red one, and the red litmus into the blue one by the bases. But every time it is not possible to check out the acid and bases on the basis of their property. We can't take a sip of acid every time to check out if it is acid or base. That's why the various scientists came out and they designed a various tests. They give the various property to make the classification between the acid and bases. So we are going to talk about the first scientist, Arrhenius. Arrhenius makes the classification of acid and bases on the basis of the ions produced by the substances. According to Arrhenius, acid is a substance when dissolved in water, for example HCl. When HCl is dissolved in water, it gets dissociated into the 2 ions, H plus and Cl minus, aqueous, aqueous. So simply according to the Arrhenius, the substance which produces the H plus ion in its aqueous solution is called as a acid. At the other hand side, when the NaOH is dissolved in water, it produces the 2 ions, Na plus and OH minus. So Na plus aqueous, OH minus aqueous. So simply the substance when dissolved in water produces the OH minus ion. It is called as a base. So this is simply classification between the acid and bases on the basis of the ion produced by the substance. The substance which produces the H plus ion, proton ion in its aqueous solution is called as a acid, while the substance which produces the OH minus ion in its aqueous solution is called as a base. So the concept of the Arrhenius for the acid and bases. As we are discussing about acid and bases, first of all we make the classification between the acid and bases on the basis of their property. It is a classical concept. Second thing is that according to the Arrhenius, the substance when dissolved in water and produces the H plus ion is called the acid. and the substance which dissolves in water and produces the OH minus ion. It's called a base. That's why HCl gives H plus ion is the acid, and NaOH gives the OH minus ion. It is a base. But rather than that, the next concept today we are going to discuss about it is Lowry and Bronsted theory. When you look out the reaction, when you look out the forward reaction, you observe that the HCl becomes Cl minus ion in its aqueous solution. HCl becomes Cl minus ion. It is possible if HCl prefers donation of H plus ion. So substance which donates H plus ion is called an acid, according to Lowry and Bronsted. In the same forward reaction, NH3 becomes NH4 plus. NH3 can become the NH4 plus by gain of H plus ion, so it is called as a base. So these are very simple concept of the acid and bases given by the Lowry and Bronsted. The substance in aqueous solution, if donate H plus ion is the acid, and the substance in aqueous solution donates the H plus ion is called as a base. But when we take the consideration of both reaction forward and backward, we found that the two acid base pairs are formed here. In a forward reaction, HCl becomes Cl minus ion. So it is acts as acid because HCl donates H plus ion. But when we look out the backward reaction, Cl minus ion becomes HCl. It is possible if and only if it gains H plus ion. So in a forward reaction, HCl donates H plus ion, so it is acidic in nature. But in the backward reaction, Cl minus ion becomes an HCl by gain of H plus ion, so it is a base in nature. So let's talk about only HCl and Cl minus ion. HCl becomes Cl minus ion by loss of H plus ion, so it acts as the acid, and Cl minus ion becomes HCl by gain of H plus ion, so it is a base. So when you look out the nature of HCl and Cl minus, it is clearly found that it is an acid base pair formed from each other. It is an acid base pair formed from each other by mutually loss and gain of H plus ion. Such acid base pair is called as a conjugate acid base pair. We again have a second acid base pair, conjugate acid base pair in a given example. Let's talk about the NH3 and NH4 plus. NH3 in a forward reaction becomes a NH4 plus due to a gain of H plus ion. So it is a basic in nature, acts as a base. But in a backward reaction, NH4 plus becomes a NH3 due to loss of H plus ion. So it acts as a acid. So again, NH3 becomes NH4 plus due to gain of electron, and NH4 plus becomes NH3 due to loss of H plus ion. So it is a acid base pair formed from each other by mutually loss and gain of proton, that is a loss and gain of H plus ion. It is also called as a conjugate acid base pair. So in a given example, we have the two conjugate acid base pair, the HCl, Cl minus ion base, and here NH3 and NH4 plus. So we have the two conjugate acid base pairs, HCl and Cl minus ion, NH4 plus and NH3. So guys, still we discuss about acid and bases at a different level. The first thing is that the classical definition. The second thing is that the theory given by Arrhenius, and the third one that is the Lowry Bronsted acid base theory. Right now we are talking about the new theory for the classification of acid and bases, that is the Lewis acid and bases. So let's look at this example. In this example, NH3 is the species with a lone pair of electron at nitrogen. So nitrogen in ammonia having a lone pair of electron, while boron in BF3 is an electron division species. So what happens? Nitrogen loses a lone pair of electron. Nitrogen gives a lone pair of electron to boron to form the coordinate bond. So simply nitrogen having ability to lose lone pair electron. The substance which can lose the lone pair of electron, the substance which can donate the lone pair of electron is called as a base. while BF3 is a substance in which a boron having the electron diffusion center. So BF3 having the ability to accept lone pair electron. So substance which can accept the lone pair of electron is called as an acid. This is what a very simple concept of the acid and base given by the Lewis. Substance which can donate or lose the lone pair of electron is the base, and substance which can accept the lone or base is called as the acid. This is what the classification of acid and bases on the basis of the Lewis theory. Let's talk about the new concept, that is amphoteric nature. When water allowed to react with NH3, so in this reaction NH3 becomes NH4 plus, producing the OH minus ion. So when you look at the forward reaction, you simply found that H2O becomes OH minus ion. H2O becomes OH minus ion by loss of H plus ion. So according to the Lowry constant, the substance which loses H plus ion is called as a acid. So in above reaction, water shows the acidic nature. But when H2O is allowed to react with HCl, so in this reaction H2O becomes H3O plus hydronium ion and Cl minus ion. So what happens in this reaction? H2O becomes H3O plus. It is possible due to gain of H plus ion. So in this reaction H2O becomes H3O plus by gain of H plus ion. According to the Lowry constant, the substance which accepts the H plus ion is called as a base. So we can find the two different nature of the water into different reaction. In our first reaction, H2O becomes OH minus ion by loss of H plus ion, so it is acidic in nature. In second reaction, H2O becomes H3O plus, that is hydronium ion, by gain of H plus ion to the basic in nature. So substances which have the ability to show the both acidic as well as basic nature. The substances which show the acidic as well as basic nature, such substances are called as amphoteric in nature.